Hello and welcome to my video on what is a power, topic 2.1 from the Math Makes Sense 9 book. So this is just an intro video to powers in general, and so we're going to start off with a very simple definition part. So our definition, we're going to start off with the number 5 to the 3, 5 to the third, or 5 to the exponent 3, or 5 cubed. All of those work as the same thing, and they all sound very, very similar. The only one that's kind of different is cubed. Now, cubed is special, and squared is special. They're just special names for it, so just keep that in mind. It's kind of like 11 doesn't follow the rule 1-teen, or 12 is not 2-teen. But then we have 13, which is like 3-teen, and then 14. Okay, so it's kind of like how 11 and 12 don't fit that rule. Squared and cubed don't fit that rule. So we have this number 5 to the 3, and we have the whole thing that we call a power. So the entire thing I circled in red, that is the power. And in the top right corner, we have this thing I circled in green that is called the exponent. So sometimes I'll say 5 to the 5 to the exponent 3. That's what I mean. And lastly, we have the thing I circled in blue, which is the base. Alright, so with those definitions out of the way, we can move on and use those to help answer questions. So we're going to get started right here. Write each power as repeated multiplication. So we're going to have to notice two different things. We're basically, the biggest thing is to notice that the exponent is only talking about whatever is directly to the left. Maybe I'll use a different color. Directly to the left. So 6 is talking about the 4. 3 is talking about not the 7, but the bracket. Okay? So with the 6 talking about the 4, we're going to take the negative out, and we're going to do the 4. So 4 times 4 times 4 times 4 times 4 times 4. Okay, bracket. Okay, so the negatives outside of the brackets, and then we do that. With the second one, the 3 is talking about the bracket, which means that we're talking about the entire thing. So it's from the first bracket to the end bracket. So just be aware of that. So this entire thing is the base. So bracket minus 7 bracket times bracket minus 7 bracket times bracket minus 7 bracket. And we could put a little times sign in between, or we could put a dot in between. There's multiple options for what people do, or you could leave it blank in between. Any of those options are fine. Alright, looking at this next question, we have write each power as each product as a power and then evaluate. Now, I'm going to talk about how to evaluate in a second, but we're not actually going to do it. Okay, so because I can't show you a calculator right now, I can't do it, but I'm going to talk about what your calculator would, how you'd type it into your calculator. So write each product as a power. First, you have to realize what the base actually is. The base is from here to here, here to here, here to here, not the first negative in this case. Okay, so leave that negative out, and then write your base. And how many times does it show up? In this case, 3. Now I'm going to count this one. 1, 2, 3, 4, 5. 5 to the 5. Okay, so those are our two products as powers. Then evaluate, it says. Now, if I were to do this on a calculator, I would write out exactly like this. Negative, bracket, negative, 4, bracket. Now this is where you have to know your calculator. Your calculator could have multiple options here. Or, well, it'll have one of the following options. So either a little mountain looking sign or an arrow up that says to the exponent. So it's like up, right? So it's up here, up top, right? That's how I think about it. So that would be one symbol. Another possible symbol is x to the y or y to the x. And then my calculator has x, and then it has a little box here for an unknown. Any of those are possible, and it's possible even that you have something else. Those are just the common ones. So you would type minus bracket minus 4 bracket and then a 3. Okay, and then you'd press the equals sign. Don't press equals in between. And this one over here would be very similar. 5, and then you do your sign. So I'm just going to do one of them. This little sign, and then 5 equals. All right, so that's how you do it. We're not going to evaluate it here today. Now this next one here also says then evaluate. We're going to ignore that. But it says predict whether each answer is positive or negative. So I'm going to show you a little flow chart here. And we're gonna start off here with a very simple, is there a minus sign? Minus sign? Question mark. If there is no minus sign, you can stop right away. No minus sign means that it's positive. If there is a minus sign, you're going to need to keep working at it. Then you're going to ask yourself, are there brackets? Brackets. If there are no brackets, easy peasy, your steps are done. No brackets means it is negative. No brackets and a minus sign means it's negative. Otherwise, there are brackets. Then you ask yourself, are they in the correct position? And I'm going to talk about that in a second. But are the brackets in the correct position? If they are not in the correct position, then we know that our answer is negative. If they are in the correct position, we finally get to ask ourselves the last question, which is, what does the exponent look like? Is it even, or is it odd? If it is even, after all these steps, make sure you do the first, like you need to go all step by step. If it is even after all the steps, then it is positive. If it is odd after all the steps, then it is negative. Okay, let's apply this right now. So we have 4 to the 3. Is there a minus sign? No. Okay, so it's positive. So we can stop right there. We're done. Next one. Is there a minus sign? Yes. Okay, we need to go over here. Are there brackets? Yes. Are they in the correct position? Okay. Now I need to answer this question. Yes, this is the only position where it would be correct. If the brackets were like this, or like this, then it would be in the wrong position. Okay, in which case it would be negative. Okay, so it is in the correct position. Now we go to exponent. Is it even or odd? In this case it's even, so we can add a little plus sign. Okay, let's try the next one. Minus sign. Is there a minus sign? Yes. Okay, are the brackets? No. Boom, we gotta stop. Negative. Okay, next one. Minus sign. Is there a minus sign? Yes. Okay, are there brackets? Yes. Are they in the correct position? Yes. Is there exponent? Yes. Is it even or odd? It is odd, which gives us a negative. All right, hope that helps. And here's another question. This one is, I like it a lot. Write each number as a power with base 2. Now, whatever base you're given, you can do this with that, okay? So let's start with 4, because it's a nice easy number to work with. So 4, if we want to figure out what the number is in base 2, we divide by the base that we think it is. So divide by 2 to give us 2. We keep dividing until we get to 1. Like that. Okay? So we divided once, twice. Okay, so we divided twice. So that means we have our base 2, we divided twice, so our number up here is 2. Now that's easy because we already know it's a perfect square from the last topic, but now we know this. Now we're going to go on to a little bit harder one. 32, let's do this same process. Divide by 2 equals 16. 16 divided by 2 equals 8. 8 divided by 2 equals 4. 4 divided by 2 equals 2. 2 divided by 2 equals 1. How many times did I do that? Once, twice, 3 times, 4 times, 5 times. So 32 is 2 to the 5. Okay, now 128. Now I'm going to tell you there's 2 ways I'm going to show you how to do this. One is exactly the same as before, and we can do that. It's just going to take a little bit of time, but we can totally do that. We're going to do that first. So 128 divided by 2 equals 64. 64 divided by 2 equals 32. 32 divided by 2 equals 16. 16 divided by 2 equals 8. 8 divided by 2 equals 4. 4 divided by 2 equals 2. 2 divided by 2 equals 1. Oh, finally we made it. So 1, 2, 3, 4, 5, 6, 7. So we divide by 2 7 times. Now we can write that right here. 2 to the exponent 7. The other way to do it is once you already have a bigger number, we can actually reverse. And it'll make more sense once you get to later topics. But for now, just trust me on this. We can reverse. And this will be really cool once you get to those later topics. You'll see why. So we already had that 32 was 2 to the 5. Now we're going to just multiply by 2 until we get to our number, 64. Multiply by 2, 128. Okay, we're at our number. How many times did we multiply by 2? Oops, wrong button. I'm messing stuff up here. There you go. How many times do we have to multiply by 2? Twice. Okay, so we had to multiply by 2 twice, so we had already 2 to the 5. And we had to do that, we had to add it twice more, 2 to the 7. Now if you see that, 2 to the 7, the same thing as 2 to the 7. It's amazing. It's a miracle. Okay, so we've got it. So that one's done. But I would stick with dividing by whatever the base is, whether it be 2, 3, 5, whatever it is. You can divide by the base. This multiplying thing, some of you might use it, but it's more of an interest thing. Okay, last question here. Here are the powers in each pair. How are they the same and how are they different? We're going to start off with these 2 pairs that I've shown here. And I showed it in repeated multiplication because this is how my computer does it. It only does the calculation for me if I write it like this. Who knew that it was actually a useful skill? So see, shows me that one. Let's see here again, shows me that one. So we got those 2, which is the first set, right? That's this set here. And I'm going to say that this one here, what was it? 4 to the 5. Well, 4 to the 5, the exponent is higher. So I'm going to write that down. Exponent higher. All right. And the other one was 5 to the 4. And in this case, I mean, the base was higher, but the exponent was lower. Okay, so what I'm trying to get you to notice is that it doesn't matter what the base is. If you're comparing 2, the exponent is what matters more. Okay, and we're going to see that here. We're going to show you again this other case now where it's doing the same sort of thing. So right here, we're doing that one next. So let's get the answers here. Okay, and let's see. Yes, so our number with a higher value, or higher, let's say this is 3 to the 5, higher exponent has a higher value. Okay, so this one has, and this one here is 5 to to the 3. So we're at 5 to the 3 there. Sorry about if there's a sort of glitch there. My video cut out. So what I want you to notice here is that we have a higher exponent in the green here, which means a higher value. And with the red, we have a lower exponent, which means a lower value. So I'm just going to try that right now. I'm going to put that down, not try that. I'm going to put that down for this one as well, because it's true for this one. We still have 3 to the 5. The exponent is higher. 5 is higher than 3. So it's still a higher value. So I want to say that this is a general rule that's almost always true, except for these extreme cases. And the extreme cases are on the very, very lowest end of numbers, which actually makes it really easy to remember because you can actually just calculate it in your head if you need to. So these are the two cases. So either we'll have 2 to the 1 compared to 1 to the 2. So if we do that, we just have 2, and 1 times 1 over here, which is just 1. So 2 is bigger than 1, but the exponent for 1 squared is higher than for 2 to the 1. Okay, so that's one option. The other option is 2 to the 3 versus 3 to the 2. Now this is the other extreme case, so 2 to the 3 is 2 times 2 times 2, which 2 times 2 is 4, times 2 is 8, and then 3 times 3 over here, which is just barely bigger at 9. Okay, and again, the exponent is lower, but the value is higher. So there's two cases that are sort of contradictory. But most of the time, we can say that this holds true. If the exponent is higher, the value is higher. So keep that in mind as we look at comparing numbers. Usually that's what it's asking. Some sort of comparing in terms of size. So keep that in mind. The other thing I want you to keep in mind is that the numbers are different. So the values of 4 to the 5 versus 5 to the 4 are significantly different, and same thing with 3 to the 5 versus 5 to the 3. So the values are significantly different between having a base or having the exponent, the number. Yeah, so I hope that video helps explain what a power is, and I hope these example questions give you some idea of what to look for. Good luck!